You're watching another episode of Late Night Docker. What is up? All right, tonight I'm working on a project actually for the Swarm Mastery course. And I thought, well, I'm kind of got to work through some of this stuff, figure out how I'm going to do the assignment in the course. And I thought, hey, why don't I just live stream this so people can ask questions, sort of watch me work through the problems. It's probably going to take me an hour at least to kind of get this whole thing worked out, but I'm available to chat. Any questions you have on Docker or any of my courses, I probably should put something up on the screen. The URLs for that actually are, let me pull up something, Visual Studio Code. So yeah. So the content actually that I'm working on tonight is for the Swarm Mastery course. That's actually at www.swarmmastery.com, which is a follow-on course to Docker Mastery, which was my first course. These are both on Udemy. Those URLs will get you coupons. You're probably already taking the course, which is how you found your way here anyway. So, but the Swarm Mastery, I'm still actually finishing up some of the later sections that are a little bit more advanced, and this one that I'm finishing up this week. Hopefully, it'll be published in the next week or two once we get all the editing, closed captioning, and all that finished. Is around Swarm updates, Swarm rolling updates, health checks, Swarm rolling update rollbacks, failed containers, and how those react in certain situations. All sort of what I would call the day two operations stuff, where we deploy an app on day one, and that's the only time we ever deploy that fresh. From then on, it's what we know in the industry as day two operations, which are the things you do from then on out. Everything you do about backing up, monitoring, replacing, updating, all the things you have to do to an app once it's initially deployed the first time. Those are day two ops. And those are typically horrible, painful things to do. They're usually very hard to do updates with near zero or, legendary true zero downtime rolling updates or blue-green updates. So it's actually all really hard stuff to do, I think. And it's not like Swarm or Docker or anything magically solves all these problems for you. But it certainly makes it way easier to get near zero downtime right out of the box with just a few little changes. So what I'm actually going to do is I'm going to use something called the voting app. Let me pull that up here, voting app. All right, so the voting app is a sample app from Docker, and they have had it for years. That's not this. This is the class. Let's look. Let's see what I got here. Okay, example voting app. So I actually forked this, I don't know, a year ago or something from the Docker samples example voting app. And really what this is a distributed app that simulates a very simplistic voting app, basically cats versus dogs. And it's a multi-tier app with a typical workflow where you have the client web front ends that then need to talk to maybe some sort of queuing system. In this case, that's Redis, where it stores the votes of dog versus cat. And then you have this worker that checks Redis for any work to do inside the queue. It will then process that work, then store it in a long-term database. In this case, that's Postgres. And then we have the result, or sort of the admin database of this simple app that would be maybe, looked at by the application owner for who's winning the votes, dog versus cats. So it's a pretty simplistic, contrived sort of solution, but it allows you to do all sorts of examples around how to deploy and maintain container-based solutions of a distributed multi-tier app. So I like using it for a lot of my examples. And it's amazing how far you can take this thing, because in this case, what I'm doing is I'm going to be using it to teach and help students in that class, in that course, figure out how to do rolling updates with near zero or hopefully someday true zero downtime deployments. I'm really skeptical to always say zero downtime updates because in the real world, everything's way more complicated. And when you start paying attention to client connections and how users connect to your application, and are those long polling connections, are those web sockets, and how do your web front end servers actually talk to the database, and how long does the database take to respond to a query, and all these complexities. And if you just take one of those pieces and throw it away and then put one in, that suddenly gets very complicated at a session and connection level. So it's while orchestrators like Kubernetes and Swarm and Mesos, they all make it easier for replacing applications. They don't necessarily solve the inner problems of your application and how it handles connections and how it knows to shut those connections down and redirect those to other machines and how to wait for work to be finished before they properly exit. That's a whole lot of complexity in your app. And you can do a little bit in Swarm and Kubernetes and the others. I mean, I'm just focusing on Swarm tonight, but you can do some with the orchestrators, but you can't solve all those problems. So it really forces you to really learn your app. If you're going to be someone who's running a true distributed application in production, you have to care a lot more. Well, let's say this. If you're someone who is going to have a traditional maintenance window where you say every night or on Sundays from midnight to 4 a.m., we're going to do updates and it may or may not be down. That's great for you. That's a much easier problem to solve. If your users can tolerate that kind of downtime, then that's the only time you should be doing updates, and you should never really update outside that window unless you have a big problem. But once you get to the point where you're saying, hey, we're deploying every day, we're guaranteeing our users, a great experience even through the update cycle, then you suddenly have to care a whole lot more about the intricacies of each little nuance of updates. And it can get very nuanced. It can get very detailed very quickly. So that's what part of this whole course is about. There's a section of almost, I don't know, at this point, I think I've got about 2 hours of content just around this. So what I'm going to ask in this section when it gets launched in a week or two is I'm going to be talking about all the different things that Swarm can do to help alleviate downtime. So this is an example stack file. Hopefully you're familiar with Swarm and you know stack files. They're very similar to compose files that we'd use with Docker Compose on your local machine for local development. And so I'm just going to be working through this for a while on how to make this stack compose file more awesome by adding features in it such as health checks and rolling update options and rollback options and shutdown timeouts and stuff like that that will help make it this more resilient and allow the update cycle to be more highly available or less downtime or lost connections during an update cycle. And by the way, if you're just joining us, you have questions, you want to talk about Docker, feel free to throw those in the YouTube chat, and I will hopefully see them after a few minutes and we can talk about it. All right, so the first one up here is Redis. So I have a Redis service in this app, and Redis can be both simple and complex at the same time. So I know that if I go over to the internets, let's see, where do I have it? Where's that tab? I think I closed it. Hey, Fabian. Cool. Nice. Rodrigo, your course on Udemy was my first contact. Cool. I'm glad I could be the first time you learn it. Hopefully you learned the good stuff instead of the old stuff that's likely wrong at this point. Cool. Evangelist. Well, obviously that's exactly how I got started. I started using Docker a long time ago, 3+ years ago, almost 4 years ago, and yeah, I got pretty excited too. Like it was hard to get working back then, but once I got it working and I had figured out what it was supposed to do, and not what I thought it should do, it got really great, and I became very quickly an evangelist for it with my friends, and then I started talking about it, and then here we are, right? 4 years later, who would have thought? Changed my whole career around and do nothing but Docker stuff now. So good. I'm excited to hear about that. Hopefully, it'll go well for you, and you can keep us posted in the community chat. All right, so I'm going to use a health check here for Redis. I'm going to basically cheat. Instead of making up a custom one on my own, Docker has this library at github.com/Docker library/health-check. They have some examples, and these examples are really for database or data storage systems, because those tend to be a little more tricky than just curling a URL for health checks. So in this case, this is actually a pretty simple little bash script that does a Redis CLI. You can actually see it here. It does a Redis CLI against the container, against the app running in the container. And the whole premise behind health checks here is that Docker or any other container runtime doesn't actually know what your app is doing and whether or not your app is truly ready for connections. So whether you're using Swarm, Kubernetes, or anything else, you've got to have health checks. Absolutely, before you go to production, everything has to have health checks, because otherwise you will have downtime when doing any sort of update, because Docker will make your container available for connections before it's actually ready for connections. And so the health check, and also the health check gives it more intelligence to know whether or not it's truly healthy, and if it's not healthy, it deletes it and recreates it, right? So Fabian, I hope I'm saying that right. Kubernetes is gaining popularity. Yes. So Kubernetes is definitely the number one full open source solution for container orchestration. It is by no means the only one. I think it gets a lot of the attention right now because largely due to so many people in the community. I mean, it's basically got its own conference at this point, the Cloud Native Conference, KubeCon. And it's used by a lot of large teams. The real caution I usually give to people is that it's really hard to get started with. I mean, you can use a mini kube and run that locally. Docker makes it a lot easier now with Docker Desktop. You can run a little kube system, but everything in Kubernetes is going to be more work than in Swarm. I would say everything. Most things are going to be more work in Kubernetes than in Swarm. So my attitude, and I'm not downplaying the positives of Kubernetes, it is a very awesome system that is used by lots of big teams to do lots of really great things. It's just not necessarily what everyone should be using. Swarm's sweet spot is in small teams and individual DevOps people, or basically if you're in a team of less than 3 full-time DevOps people that are going to run this thing, I would not do Kubernetes. Or if I did Kubernetes, it would only be a third-party hosted solution where they completely take care of the cluster for me. Such as AWS's higher end offerings where they manage the nodes. Because otherwise, there's a lot going on in Kubernetes. It's a distributed microservice system. Swarm is an all-inclusive, all-in-one, built inside the Docker engine. It is, by pure nature of its design, way easier to get started, way easier to run, simple to use. It doesn't have the community that Kubernetes has. So if you want edge case scenarios, or if you want a lot of weird complexity that's not necessarily used by most people, then you're going to probably find that sort of third-party support in the Kubernetes ecosystem before you'd find it in Swarm, right? So for every tool that you can find that Swarm, that works well in Swarm, you'll find 25 or 50 of them in Kubernetes. For example, there's over 60 different projects for how to deploy an app in Kubernetes. It's overwhelming to choose something like Helm or another solution for that. In Swarm, there's really just one. It's the compose file. It's the stack file. It is the standard. Now you can choose multiple different GUI options. There's at least 3 that I know of that are still working out there that are nice, good GUI solutions, but for deploying that compose file. But there's one format, there's one solution. For example, if I make a compose file for Swarm to deploy this app we're doing, voting app, in order to do that in Kubernetes, it will probably have to be about 3 times as much YAML, just to do the same exact thing in Kubernetes. So it's not that Kubernetes is bad. It's just that I, I get a lot of students and a lot of people that are new to Docker and are small. They're small teams, or they're the only person in their team that's going to do this. And I think for most of those people, Kubernetes is the wrong choice because it's going to be way more complexity than you need. Um, and unless you're doing something and at the scale of, let's say, more than a few hundred physical servers, you probably can be fine with Swarm. And then you won't need Kubernetes or the burden of overhead that it requires. That being said, they're all really cool to check out. Like Mesos is cool to check out. Kubernetes is cool to check out. Swarm is cool to check out. I encourage everyone to play around with them and figure out which one they really need. But I don't think that starting out, if you're small, meaning you only have 100 containers, apps that you need to run, that you would need to go to the links of what's required in order to deploy a fully secure, fully redundant Kubernetes solution in production. If you're really all on board the Kubernetes train, and that's fine, and you're small, then you definitely want to go with something like Fargate or Google's solutions for managing your Kubernetes cluster so that you never have to worry about certificates and back-end uptime of etcd and all the other stuff that's inside of Kubernetes. It just gets it gets to be a lot of work, a lot of maintenance, and a lot of monitoring and details that it's really hard for one person to do all that. Where Swarm, since it has a much simpler architecture, you can basically 3 commands and you have a fully redundant Swarm. So it doesn't get a whole lot more complicated than that. So it's a great question. I get it a lot. And it's hard to choose. It's just like saying, what should I use, Chef or Puppet or Ansible or SaltStack or whatever. I mean, should I use JavaScript or Go? Like there's a lot of decisions in IT, and it doesn't necessarily mean one is always better than the other. I'd say different strokes for different folks. So what I'm going to do is I'm going to copy out this. I'm going to make myself a config file. Rodrigo, yes, absolutely. I know I have internet startups with millions of users on a single Swarm. I have clients that are large colleges with what I would assume would be hundreds, if not thousands, of apps that they're all migrating to Swarm. International accounting firms using Swarm in their data center. Basically, until 3 months ago, every Docker enterprise customer, which there was over 400 of them, all were using Swarm. So any Docker Enterprise Edition deployments were using Swarm. And I think just because Docker deployed, they're offering now 2 orchestrators. They technically, they don't talk about this, but technically they offer 3. They offer with their Enterprise Edition Swarm Classic, which was deprecated years ago, but they still support and they still deploy with Enterprise Edition, and then the Swarm mode, and now Kubernetes as the 3 options. The Swarm mode is actually still the default in the current version of Docker Enterprise Edition, and they have actually a new team, some new people on the Swarm team, and we actually just had a briefing the other day about all their plans for Swarm and hopes for how they're going to make it better, add more features. I think this whole year, if you look at the commits, they've been committing a lot of new code, tens of thousands of lines of code to Swarm over the last year, really, and it's mostly been improving the scalability and the resilience of Swarm. So that's really great because nobody wants to use a product that's unreliable, regardless of how many features it has, right? So they've been really, really focused on that, and I think we'll hopefully by the end of the year we'll start seeing some new features rolling out, especially my hope is by Docker EU in December, we'll have some new stuff to talk about with Swarm in terms of feature set. But I think right now they're just focused on quality. Joshua, what's up? Yes, I when I'm working on my videos, I tend to stay up late. Hence, late night Docker. All right, so on this one, I'm gonna have to add a health check. And I think what I'm going to try to use is a config. All right, so I have the health check script. You're welcome, Rodrigo. And you're welcome, Fabian. So I'm just going to cheat. I cheat all day. Although, is that under deploy? I don't know if the health check is under deploy. I don't think it is. No, it's not. Mm. So what I'm doing right now is I'm adding a health check to Redis to improve its uptime in theory. So if Redis has a problem, then, and I want to shorten this actually, I want my interval to be 5 seconds. And 10-second timeout seems really high. I think 5 is the default. So I'm going to use 3-second timeout. I'm not going to be that aggressive. 5-second timeout. And then it has to fail 3 times for the health check to say, oh. All right, so I'm going to give it 60 seconds to start up. So in case maybe for some reason Redis is really slow to start, I'll give it 60 seconds before the health checks start counting towards the negative. So basically it'll ignore health checks if they fail in the first 60 seconds. Hot tip, if you're running a health check, this start period here does not mean it will completely ignore health checks for 60 seconds. What it actually means is it will ignore failed health checks for 60 seconds before it starts considering something wrong with the container during startup. If your health checks start passing in the first 5 seconds, then it will count any future failures towards the crashing or the replacement of the container. So sometimes people have startup scripts for their databases that maybe do some fancy things like create users or import data or something like that, or run database schema updates. And if they do that And the database, while starting up, does that in a way where the database is, let's say this is entry point script, and the database actually becomes available on the port, and then the health check passes, and then the database has to stop and pass out of the script from an entry point into the command. In that scenario, and that gets a little complex, but in that scenario, you will have failed health checks while the database is down and restarting. And most people can't figure that out, and they can't figure out why their health checks are failing. And that's because the start period is just for ignoring negative health checks. Once a good health check happens, it suddenly thinks, okay, well then this container must be good forever, so I'm going to start counting health checks. Anyway, once you get to fancy startup scripts, that can potentially bite you. Let's see, deploy. So we're going to do the health check, and I also want to do some update options. And we're going to do some configs. And so what I'm going to do here is I'm going to actually create this health check. I'm not going to create a special image for Redis with my health check in it. That's the whole point of having configs. So I think it's plural. And then I think that's the short syntax. So I'm going to do actually the long syntax. It's a little easier, especially when it's an executable. I want to make sure the mode on it is executable so that it can run. So let's see. Yeah, I want read and execute. So I want 5. I kind of want a 555 there, I think. That way it'll stay sorry, what am I trying to say? The script will still work even on Windows. So interestingly, if you're running Docker for Windows and you try to mount something in from Windows to Linux in this case, it won't always keep the right permissions in executable because Windows doesn't have a concept of an executable in terms of permissions like Linux does. So this helps me avoid that by making sure that when it's put in, it has the proper execution. So let's see. All right. And then I'm going to need, so just like the example shows, I'm going to need to put this down. Let's see. I'm going to do that. By the way, I am listening to the Tron soundtrack. In case you're wondering how much of a nerd I am. The Tron remix. by Daft Punk. It's pretty great, from the last Tron movie, the second Tron movie, technically, not the Tron movie. Rodrigo's got another question about DevOps teams. Any tip to auto-promote an app update a new image to the cluster? We have TFS right now, and we're migrating to Visual Studio Team Services. Auto-promote an app update to the cluster. Okay, so when you say auto-promote, do you mean auto-deploy the, like, in other words, when we make a new commit, automatically build the image and deploy it to the cluster? Is that what you mean? That's continuous deployment, continuous. Yeah. All right. I'll wait for that. We got a little bit of lag between me talking and this going on the internet, so sometimes I have to wait. All right, so that is looking good. Okay, I've got the config. That should automatically work. It's going to run that. Yeah, that's what I thought you meant. Yeah, CI/CD. So I have never used Team Services, so I don't really have any recommendation for you, other than what most CI/CD solutions do is they have one of two options with Docker. Docker has an API that runs on TCP. So if you put the Docker engine binary inside of where your CI/CD automation is running, then you can actually run the Docker stack deploy or Docker service create or Docker service update or whatever you're going to run. You can run that remotely if you have the right certificates and you have this, the client certificates in your CI/CD and it properly. That's a more advanced, complex solution. The easier way is just to have your CI/CD SSH into one of the manager nodes and run the commands remotely. And so a stack deploy command, you would have the compose or the stack YAML inside of one of your repos. It'd either be in the source code repo of one of the apps or would be in a separate DevOps repo. It's really up to you how you do that. And then either if that file changes or any of the apps that it depends on change, that would be something you have to build into the automation of your CI/CD to trip the, hey, I need to deploy this branch to a certain swarm, a certain cluster somewhere based on the branch names. So usually people like, if you've got a test infrastructure and you make a change to the test branch, then the CI/CD knows to automatically go find this YAML file, make sure it's got the latest version, and then run SSH into the swarm of the test infrastructure because it was a test branch that got changed, and then to do a Docker service, Docker stack deploy with that YAML file. That is probably the most common way I see it done. The more advanced you get, like for example in Jenkins, there are Docker plugins, and I know there's some Swarm plugins. They may provide a more clickety-click option for setting all that up instead of just running scripts, essentially. In your case, if you're doing TFS and Team Services, my thinking is you're using Windows containers that you need to deploy to a Windows server. So in that case, you're probably going to need to do remote PowerShell and PowerShell into the host running Docker, and then do the Docker commands from there using the YAML file. So really it's either SSH or PowerShell remote. Both work. If you're on a Windows machine, you can set up, now Windows has a SSH server that you can actually download that's official from Microsoft. And you can do it that way. So I would say start there, start with the SSH or the PowerShell part of getting connected remotely, and then just running the same commands that you would normally type, like Docker stack deploy. And Docker stack deploy will automatically look in your YAML file and determine what's changed and what needs to be updated and all that. Hopefully that helps. And you would do all that based, in Git, you would do all that based on usually branching. So people have feature branches. Like I worked on a client recently that they had feature branches, and they had epics. And so whenever that epic was created uh, as a branch, the CI/CD solution got a webhook from their Git storage solution, and it would just send a webhook to them that they would then kick off a job that says, "Oh, we need to go take that code, make an image of it, test the image, make sure it's good, put it into our image registry, and then go create a whole new stack file in a swarm that's our test swarm just for that epic." And what they ended up having was a model where a single swarm had many copies of the same app running over and over for each of the branches that they have for epics. So every time someone created a new epic in their Git, the CI, their Jenkins in their case, would automatically take a sample stack file that it had, and then make a new stack with that specific name and specific DNS names in it. And they were using AWS, so then they would automatically update Route 53 for DNS that would automatically create a new URL that would allow that specific URL for that feature branch. It's a lot of automation, but eventually they got it set it up so that all a developer has to do is when they create an epic or a feature branch, they don't have to do anything special. They basically commit that and push that to the repo, and then everything else happens. And suddenly, within maybe 5 minutes or so, I don't know how long it took them, everything was tested, images were built, and apps were deployed into the swarm, and a new URL worked on their swarm. And they just had to make sure that their swarm had enough resources, so they would do auto scaling on AWS for their swarm workers, and that just kind of works. And so when the resource would, CPU or RAM would get limited, it would just add more workers to the swarm. That's outside of the scope of what Swarm does. That's actually really just a AWS auto scaling group that runs a little script when it starts to auto join the node to Swarm. Anyway, I could talk all night about that, but hopefully that'll get you started. All right, so now I have my health check. The next thing I'm going to do is I need to add an update down here under, actually, you know what? It's going to be up here under the deploy section. So the update config. So most apps are going to need a custom update config when they go into production. You're going to want for example, this app, this is actually the Redis server. And in this case, I believe I can do, I believe I can do a update config parallelism. I'm going to delete that. I don't want parallelism. I think I can do 2 replicas of this Redis, and I'm going to try that and see if that works. You're welcome. Now, in production for updates, I almost always want my failure action to be rollback. So when you do a stack or a service update, either one of those, by default, if there's any problem with the application or the health check of that container and it doesn't finish the update in a healthy state, it will want to do something. By default, it pauses. It basically freeze frames and says, I'm in a broken state. I don't know what to do. In production, I always want to preserve safety. So in that case, if I have any problems with the new version I'm deploying, it fails health checks, it crashes, whatever, it can't download the image, it can't access the image, whatever the problem might be. I want it to roll back to the previous version as fast as possible, which means I want my automated failure action to be rollback, not pause. Pause leaves me in sort of a half-broken state where potentially I could have containers on the new version and containers on the old version. And that's an interesting choice to have that the default. I think maybe Docker was thinking do no harm by default. I'm not sure why they thought that was the good default. So I always do rollback in production and test and dev. I do one of the other two options, which are either continue or pause. Pause is again that one that leaves you in that sort of what it does do is the pause state allows you to go and dig in and troubleshoot and see what's going on, but it also leaves your app in a half deployed state. So I would rather in production roll back and then go test somewhere on a different infrastructure. In a test or dev situation, I usually have pause as I leave the pause as default, or I might do continue if I just don't care. If it's really like a dev infrastructure and I just want to see if it's going to work, I'll set continue as the default so that it'll just blast through the update even if everything's broken. And then I don't really care because no one's using it, so I'll just test it afterwards and sort of debug on that platform, even though it's broken, and try to see what's wrong. So. Order stop first. Yeah, that's the default. I'm going to do start first. And then the rollback config you can also customize. So if you're going to do rollbacks, I don't think I need anything here. Yeah, I think I want all these to be the default. And then restart policy. Oh, interesting. Rollback is 3.7 and above, so I need this to be 3.7. The restart policy, I don't think I need anything changed. By default, any. Yeah, all right, so now my Redis. So what's interesting is that I can try to just deploy this out. So I have localhost, let's see, 5,000. So I had the dogs versus cat app here, and it works. At least it should work, because I haven't changed anything yet. Ooh, look at that. It's not showing. Sometimes I have to. There it goes. Yeah. All right, so that's working. So now let me do that. Going to redeploy. Created the config. So now if I do a Docker service PS, oops, ls, meant ls. I have to get really small. And it should be deploying my second Redis instance. Maybe. I need to go in my preferences and make sure I have enough resources for all this. Let's see. Disk, yeah. 6 gig of RAM. Yeah, that should be plenty. Mm. Looks like we might have done a rollback. Huh. That's weird. My tab completion's not working. Yeah, rollback completed. Okay, so I suck. First time through, didn't work. All right, before I go to troubleshoot, let me just health check. Yeah. Ooh, is the start period? Oops. Let's see. I'm going to do a Docker service scale. This is a no-no. You shouldn't do service changes with outside the stack file once you deploy with the stack file, just because they'll be inconsistent. But I want to just test some stuff. Rodrigo, will I keep this in my channel? Yeah, I don't see why I won't, assuming that the quality is okay and everything's great. You will, if I don't make it public, just based on, you know, whatever, I accidentally expose a password or key, for example, in the video. I won't make the video public later. So if I don't make it public, ask me on Slack or somewhere else, and I will get you the URL, because I always keep them in YouTube. I just don't always make them public, depending on the length and what I do in the video and whether it's going to be interesting. I'm not sure how much posting a 2-hour long video on my channel is going to help. So if you're watching, please follow my channel, subscribe to my channel, and that'll help. That'll help me do this more often by getting more people signed up. So anyway, I'm horrible at that. I don't know how to ask for people to subscribe. I need to practice that. So yeah, just ask me if you don't see it. I probably won't post it right away, because it doesn't post right away. And I'm traveling in 2 days. So if you don't see it within a couple of days, just ping me in Slack and I can give you the URL for the private access to it. Thanks for coming. Let's see. So, okay, so it definitely works if I do two. Looks like I broke it. Oh, I know what this is. Yeah, I think I need to scale the workers too. Oh, I have it in global mode. That's lame. All right, I'm going to have to delete this and recreate. I'm going to delete the stack and try again. You follow me everywhere, even to the grocery store? I know what you mean. All right, thanks. Have fun. All right, let's deploy this puppy again and see. Hmm. Ooh. It's interesting. That's only, I have vote 1 and vote 2, but when I refresh, I guess maybe it's cookie based. It should be processing on a different container. Huh. Yeah, I broke something. I don't know what's going on there. There we go. Oh, there we go. That's what it is. You have to Command Shift R. So I have to not use the cache. Web browsers are funny. Curl commands are easier to troubleshoot because they don't include cookies or any sort of persistent connection, but web browsers do. And so I have to use Command Shift R to ensure that if you see down at the bottom, the container ID, because I have two containers running, I should be rotating back and forth between those two containers as I refresh, and it wasn't doing that, but now it is. Why I'm getting a internal server error 500, I don't know. Docker. Oh, right. Vote. Vote. Hmm. Oh, connection to Redis. Name does not resolve. Okay. That's not what we want. So this is a great example of an app that, they're demo apps. I didn't write them, and it just it doesn't, instead of dumping that error on the screen so it's easy to use, it just says meh, no good. So I have to troubleshoot myself. So in this case, Docker stack ps vote. Starting about a minute ago. Complete about a minute ago. Yeah, so it looks like my voting apps are cycling again, or my Redises are cycling. Yep. So that's what it is. Since the Redis is cycling up and down, Docker service logs Redis vote. Redis. Let's look at Redis and see if we can see why it's complaining. All right. So I bet you what's happening, and this is where you get a little nerdy. I think what's happening is my health check is failing, and if I, what I can do is I can do something very simple to just attest my health check. So Docker stack. I'm going to kill the stack. Sorry for being so small. Docker stack remove vote. And now what I'm going to do is I'm going to run a container with the health check in it. So Docker, I'm going to have to demonize it. Let's call it redis. So I'm just going to do a regular old Docker run. Not, I'm going to test this health check. I'm going to call it redis, and we're going to do a volume current working directory slash, I'm going to cheat instead of using a config. I'm just going to mount the file. I don't want those curly brackets. I don't want the mustaches. I want that. Redis health check. Let's see. So I'm going to run. It's going to be on the default network. I'm going to call it Redis. I'm going to mount the health check file in there, and then I'm going to actually go in and run it. Docker PS. Let's see if it's still running. Yep. So now I'm going to do a Docker exec and then jump into the shell of Redis with bash. And I should see that Redis file. So cool. Does it have execute? Yes. Yes. So I'm going to then just run it. And then in order to see if it exited properly, I can do a bash trick and do echo $? Which will show me the exit result of the previous command. So that worked. So I wonder why my example didn't. Read, write, execute. I wonder if the permissions are off. So over here, oh no, I may give it 555. I don't know why. Ugh. So the health check works. And what we can do actually, in case you've never done this, you can do a Docker stack deploy. Let's see, the Docker, we call it a stack file vote. What did you figure out? Figure out the hard way. I don't know what you mean. So now what I can do is I can do Docker events. And what I should see is a bunch of health checks. Yeah. So it's going to start doing an exec on the Redis health check. And then I can just Control C and sort of see what it's saying here. Okay, so it started that health check. It created started, created. So what I can do is I can do a filter, a dash F, and I think it's service equals vote. I think it's like this is how I do it. Service equals vote redis. So it'll only show me events related to the redis. I could probably narrow this down to only exec commands, but what I'm looking for is some indication that it's killing the container. And right, yeah. So it could be my compose, or it could be my So that's going to run inside, no, that's not going to run inside a shell. That's going to run directly. What? Let me go look at the examples. Am I doing that wrong? Sometimes it's the stupidest little thing, like it's the way that the exec or the way that the health check command runs, whether it runs in exec mode or in shell mode, and that can cause the script to fail to run, which isn't immediately obvious because it's getting, where are we going? Yeah, so here in the Redis, let me just go look at their Docker file. Okay, so they don't have a slash in the front of it. And they also, oh, they do put it in there so that it's immediately callable. They also have one for, I'm using the Alpine image. Yep, that's the issue. There's no bash in the Alpine image. So I can't do bash in a script unless I installed it, and I'm not going to do that. So we're going to use regular Redis. So not the most ninja foo for determining that it just fails in the bash. That and of course, when I did my test, I used just the regular Redis image, but here in this stack file, I used the Redis Alpine. So yet another thing, Alpine doesn't have bash built in, so I can't use that in my script. So I bet you, and what I'm going to do is I'm going to put this in a target like that. Yeah. Now we're doing it right. All right. Okay, so it's going to delete that. It's going to delete that, get a whole new image for Redis, and hopefully we'll be good. What I'm going to do here is I'm going to do a watch statement again on Docker stack ps vote. All right. 30 seconds and Redis is still running. Cool. I think that was it. Can't run a bash shell script if there's no bash on the container. So bash is included in the Debian default images, but if you start to use Alpine, you know that everything's a little bit harder in Alpine. And Alpine doesn't have bash. It has ASH, actually, Alpine shell. So if you want bash, you have to install it. And I'm not going to bother with that because I don't really care how lean my images are at this point. All right, so that's a minute. So that's good. Now we should be able to go back to the app. Get this thing working again. Cats, dogs. Come on, dogs. Come on, dogs. I feel like I need this little sucker to be like down here. Like that. There we go. Now, a fun little thing that I do sometimes is with this demo app. By the way, this is all. I'm going to put some of these URLs in the chat. So this is the health check repo. This is my repo for where's it at? This is the example voting app I'm using. And my courses are Docker Mastery and Swarm Mastery. But in this case, I'm going to shoot a whole, I'm going to basically flood this thing. So in this directory, no, I don't actually have it in here. I need to go into the repo. Let me code. I don't see. Here we go. Oh, right. Inside there is generate some votes. Right. Okay. So this is what I did. I couldn't remember what I had done. This is part of my demo apps. So if I've got stuff running in Swarm, right? So one of these things is a voting app. So I can Docker exec into one of these. One of the vote. One of the vote ones. So hard to see. Worker. Postgres vote. All right, so now I'm in that app. I'm actually in the container. And there's this script I put in there called generate some votes. And it basically uses Apache Bench, which is a benchmarking tool, to flood the server with a crap ton of votes. And it's basically so that I can test to see if it's got all the votes that I think it's supposed to have. So let's see. It should have like 2,000. So the fact that it's only got 1,500. No, it's got to have more than that. Yeah, so I think part of one of my problems here is when I'm trying to scale this thing, because I didn't actually build this app, I'm just trying to scale it, is I'm deploying multiple Redis engines and I'm deploying multiple workers, but I think that the way the workers are working is because they're Java is they use persistent connections to Redis, which means it's possible that I have workers that are not distributing their connections because they, in other words, persistent connections can be usually a good thing, but when you're trying to do distributed app, you really want applications to check each Redis server, and that's not really that's not really how this works. So I think what I should be doing is I'm going to have to take this down to 1. Yeah. And then over here, let's get out of there. So it's going to kill one of the Redis servers, and the workers I can scale up. So the workers, yeah, I have 2 replicas. I have 2 workers. There we go. Much better results. Yeah, I can't remember how many I do. 1,000, 3,000 votes. So yeah, that works that time. So I think that's what the problem was. Is in theory, multiple Redises could be there, but I think what's happening is that there's persistent connections going on. So the workers are only working on one database server, even though I have a virtual IP in the middle of a load balancer. The load balancer isn't necessarily severing connections. It'll honor connections as long as they're open. And what we would probably have to do in this case is we would probably, if we really wanted to have just separate Redis queues for scale or redundancy or something, we probably would need to design it so that the Java app terminates its connection to Redis every time it processes a worker job, so that on its next connection, the load balancer can switch it so that it makes sure that each Redis engine is getting connections. In this case, I think all the connections were going to 1 on the workers, but the front end was actually load balancing. Anyway, the point was is one of the Redis servers probably had a bunch of stuff in the queue. I could have gone in with the Redis CLI and actually checked and seen if there was stuff in the queue. Really, with Redis, the way that you're supposed to do high availability, in most cases, is you create a mirror of the main Redis server, and you have an offline or a standby server that's pulling in all the changes from the primary server. Um, it just that whole situation gets really complex really fast, because then you have to put something in front of Redis that does auto failover when the first one goes bad, and Docker can't necessarily do that for you because it doesn't understand the connection. So if I ever have the control of the situation, I always prefer just to have 2 autonomous Redis servers that are on some sort of storage or that's redundant, that's persistent, and then have all the connections to it terminate after 30 seconds or something, so that the load balancer can properly load balance between the 2. And that way, if one of them fails, the worst case is you lost what was in that queue. But in the case of Docker, it would really just bring up a new container, and it would still be connected to that persistent storage where the Redis database already was. So that's assuming that your Redis is set up to store connections. In this case, this one is not. This is, I believe, memory only. So one of the things you would want to do in production is go into your Redis server. And I think I have an example here. Let's see. All right. So in here, I've got somewhere in one of these million tabs, I have an example. Oh, here you go. Yeah, so this is what I want. Append only. One ping only. Name that movie. One ping only. So, all right, so over here, I've got my Redis image all fleshed out. Everything should be good. what I'm going to do is move on to get that with. I have a new keyboard touchpad set up on my Mac for external keyboard, and I'm not really good at it yet, so I kind of am bad at cutting and pasting. All right, so we've got database data. I just realized we don't actually have a Redis volume. That's bad. So let's do volumes. I don't remember. I don't remember Redis's volume location. I don't know how to spell Redis. Let's see. If persistence is enabled, data is stored in the volume/data. Well, that's easy. /data. All right, and then down here, I would need to add that volume. In reality, if I'm going to be in a swarm, I'm going to be in production, these volumes need to be on some shared storage that's persistent, and something like RexRay would be used. That's REXRAY. That would be a volume storage driver that would allow this data to store on EFS or EBS or whatever the storage is in your cloud. Otherwise, it's going to be stored on the server at local disk, and then when that server dies accidentally one day because they just decide to kill it, then you lost all your data. So I'm going to leave that for later. Right now, we're just focused on rolling update and stuff like that. So we're going to copy that. So we're going to do the same thing to Postgres. We're going to have a different health check, obviously. And we can only have one replica there as well. We're going to roll back, stop first. We don't need that because it's already there. Postgres. So I think very similar setup. So now I need to create. I need to create that. So and the nice thing here is I have this. This is actually something. This is actually something from. I don't need that anymore. This is something from the. Health check library over here. And I'm going to go into Postgres. I'm just going to check the Docker file. Yep, user local bin. That makes sense. And then I'm going to add this health check to a shell script. And this little shell script is kind of neat. What it does is it checks to make sure that it has the password and the database. And what's interesting is that it will use all of those to do an actual test on the database with the default database and selecting one row. So as long as there's a row returned, it's going to have a healthy health check. I'm going to give execute bit to, Postgres. All right, now we have two health checks. And yeah, that all seems reasonable. That all seems right. Postgres. And then I need to go down here at the very bottom and add another config. And all right. By the way, if you're in the stream and you're watching live, if you have any Docker questions, DevOps questions, this is all Docker stuff that I'm working on tonight, but I work as a DevOps person, so in theory, I might know a thing or two about something else, but pretty much I only talk about Docker. So, no guarantees. All right, so now we're going to do another Docker stack update. All right, so now it's going to replace the Postgres container and should now allow us to have health checks on our Postgres. Let's do a watch. Okay, we deployed Postgres. Come on, Redis. I don't even remember what I changed with Redis. What did I change? Container die. That don't look good. Okay, network. Where's container start? Did I see container die? No, exec die. Sorry, false positive. Okay, no idea what Redis took so long for, but we should be good. Let's go back over to our app. Let's see if it still works. Oh, you know what? It's not gonna matter anymore because I got so many votes. How many votes? How many votes? Oh, you know what? Oh, didn't want that. Where'd my vote count go? It's really weird. It just upped and left. No more vote count. So maybe I have so many votes, it just can't handle them. So what are we going to do here? Docker stack vote Docker volume ls Docker volume prune. I'm cleaning up. I got a bunch of containers. I'm cleaning up. Oh, there we go. All right. Let's do a deploy again. Hopefully this time will be the winner. And then while we're doing that, I'm going to go back here to vote. I'm going to copy over health check and config. Oof. That was dumb. All right. We're going to do a vote health check. I don't think I need scripts because in this case, all I need to do is a curl because I don't really know, because I didn't build these apps, right? Imagine I'm the ops person. I didn't dev these apps, so I don't really know if there's a health check URL. I could go poking around the code real quick just to see. Um, uh, let me go looking around and see if I can find something inside. Let's see. Yeah, it should be the Flask. Mm-hmm. Yeah. Um, so it has a post and a get, but no health check. So we're just going to have to do a curl on the endpoint and hope for the best. That's how we're going to do a health check on a simple web app. So in this case, I don't need to do a config. Oops. There we go. I'm just going to do a, you know what? Is curl in that voting app? I wonder. We're in Python. No idea. No idea if it has curl. So let's just do a Docker image ls. What do I got here? Okay. I'm just going to run this image real quick to see if it's got curl in it, so we can use that in our health check. Can't do that. That is not a thing. Docker run. Okay. Curl. No. So my choices here are either I update the image to include curl, or I build a mini little Flask, a mini little Python script that will check a URL and then exit properly. This would challenge my Python skills. Running a curl command is probably less resource intensive than starting a Python command. I don't know. I wouldn't know. Who could argue which is better to run a Python? What if we did a Stack Overflow? Oh, I'm not logged in. That's unfortunate. Let's do Python check URL script. I'm getting distracted by doing Python research on a basic script I totally don't need to do that. All right. What we really need to do is just add curl. That's the standard way to do this. I just realizing that inside my repo, I need to go in here inside. Yeah, vim dockerfile. We're gonna go, and we're in APK, so curl. Oh, curl. All right, let's see if this works. Let's see if it actually builds. Just want to make sure that curl gets in there. Yeah, cool. It works. All right, so I'm gonna have to push that up to Docker Hub because I'm pulling these images from there. Let's see what else we can do. Before we do that, I want to make this one commit. If we're in our app, and let's see what we got here. Yeah, we're just gonna do this. There's actually we have to. So in a curl command, technically curl will exit with an improper exit command in Docker, and it must, in order to comply with the health check rules, exit with an exit 1 if there's a failure. So I'm going to say here, either the curl command works or I exit 1. And I think, let me just Google that real quick. I think the examples, yeah, okay, or exit 1. Yeah. So I would put this here. And then, yeah. So I would do that for vote. And then I also need to do this for result, because result is also a web app. Let's go see if result has curl in it. So in this case, result, I think our result app is a node app. All right, so we've got here, let me just do this again. I'm going to run this Docker run. Get a shell, and then, yeah, curl's not in there. So, sucks. Oops. Oh, I don't have pigments on this machine. Okay. I need to write that down. Um, hmm. All right, this is running node. It's not doing. Is this no? This is this is doing Alpine. Okay, so cool. Docker file. In fact, vote Docker file. I can just cut and paste this command. All right, we've changed both of those, so that'll get curl the next time we do it. And then what I can probably do is from vote, just take all this stuff. So if I go into worker, I think there's a, let's see, yeah, this is a copies over some source code, use OpenJDK. It's doing a multi-stage build, copies over the jar file. So how would I health check a Java console app? It doesn't have a port open. I'm just going to Google this, do a Hail Mary. Um, mm, yeah. I don't see no Java in there. No. That was a fail, Google. Let's do a quote. All right. What you must not Docker features. Yeah, these are all endpoints. Yeah, so I don't think that without really studying this application and looking and seeing if there's anything inside the app that's exposed so that I can talk to it from outside that app, I don't know that there's any way to tell really from this app. So I would have to be a Java developer and look at the source code and figure out where I might be able to talk to the API of that, if it even has one, or if it's just a binary that's sort of let's get back in there. That's sort of a black box from the outside. Oops. Hmm. Yeah. Don't really think there's any way to make this work. I mean, I could have a third-party monitoring solution that's checking the databases for making sure the records are getting updated and that their queues are not getting backed up. That's what you would want to do with third-party, but simply for making sure this container is running, I'm not smart enough to know about how to do that in Java. So we're going to leave that one out. We're going to skip that one and just say that not an option. But what we can do, so we're going to disable the health check. We're going to deploy 2 of them, and we're going to roll back, get rid of that. That's duplicative. Oop. All right, I think we're good. I think we're ready to rock and roll. All right, so one thing I need to do, though, is do a commit here.